All right, so we're going to do in section 4.6. This is polynomial inequalities and rational inequalities. So last time we did inequalities with absolute value, and now we're going to do it polynomials and rational. So this gets a little bit more complex, but the actual computation isn't too bad, right? It's not as simple as the absolute value. Absolute value is pretty straightforward, but for this, because we can have various things. Let me open up Desmos real quick. I kind of want to show you what's going on in Desmos, and then we'll solve the problems. Yeah, so I want my graphing calculator. And so how we solve this is the following. We're going to get our polynomial. So we're going to start with solving polynomials. The other page will be solving rational, okay? So to solve the polynomials, we're going to get our polynomial on one side of the inequality and a 0 on the other. And we definitely want a 0 on the other. We're going to solve or factor. So all the things we learned how to factor and solve and all that division stuff is going to come into play now. We're going to mark all the zeros on the number line and test points in the interval and mark the sign. And then write the interval for the sign you need. Okay, so and what do I mean by that? Means this is greater than, write all the positive ones, right? If it's less than, write all the negative ones. Or if it's write all the negative ones, because this will always be 0. Okay, so let's show you how it's done, and then I'll show you we'll do it. We're going to do the first one we're going to do, and then we're going to look at the graph, and then the next one we're going to graph, and then see how that will match what we're going to do by hand, okay? So the first one here we just want to find the zeros of this, or aka we factor it. So here we're just going to factor this, and so we have x minus 5, x plus 1, right? So that's how this factors. So once we have that, we're going to make a little number line here. And we're going to put in those zeros. So here we have the 0 of -1 and +5. All right, so we're going to test some point in between it. So the point I want to test in between it, we're going to test 0. We're going to test 0. I don't know, let's see what's a good way to do this. So we're going to test 0. No, I'm just going to put 0 up and circle it here. We're going to test 6, I guess. 6 isn't a bad one to test, and we'll test -2, I guess. And just test some points. So these are my test points. These are my zeros, right? And then we're going to have our signs. So a -2. So let's put -2 in here. So I'll have -2 minus 5 would be -7 times -2 plus 1 would be -1. So -7 times -1. All I care is the sign. So that is positive because I'll have a negative and a negative. Okay. Here I'll put in a 0. So it'll be -5 times 1. Once again, all I care is the sign, and the sign is negative because I have a negative number times a positive number. So this is negative. So here this is negative, this is positive, and so I have a negative down below. Here, if I put in a 6, this number is positive, this number is positive, so it's positive overall. And so it's positive. So here we found the zeros, which would be 5 and -1. We're just going to pick points in each of the intervals that we have, because this will split my number line, right? So I'm going to pick something to the left of it, -2, something to the right, 0. And then here, I already have something to the left, so I only need something to the right, which is 6. So notice here I want greater than. So since I want greater than, I'm just going to choose the ones which are positive, right? So the intervals which are positive. So here would be everything up to -1, so -infinity to -1, union from 5 to infinity. And notice since we have strictly less than or strictly greater than, we want the zeros, we won't include the zeros. And this one we will, because we have less than or equal to. So here, this will go from 5 to infinity. So let's graph this and kind of look at this graphically for a second. And that will help kind of understand what's going on. So we're going to graph this. We'll have x, we just have this Desmos right here. Hi, Desmos. I'm going to type in x squared minus 4x minus 5. All right. And so this is what we have. And so here are zeros, -1 and 5. And notice when I test the point 0, I got a negative number. When I test the point 2, I got a positive number. And when I test the point 6, I also got a positive number. And so we want this polynomial to be greater than 0. So where is this greater than 0? Well, everything up to -1 and from 5 onward to infinity, right? So negative infinity to -1, 5 to infinity. And so that's all we're doing here. And so if you have trouble making test points, you can always just graph the thing, at least for this class, because we're remote and you always have a graphing calculator next to you, aka Desmos. Just open another tab. But you do need to know the zeros. Okay, so let's do it by hand. Let's do the next one. Let's get it to the point where we can do it, graph it, and then we'll do it by hand and we'll see it matches. Okay. So here, I haven't done, if I was going to write these as steps, right? This would be 1, this would be 2, this would be 3, this would be 4, this would be 5, right? Here, step 1, I need to get px on all on one side, right? So here we're just going to move over the x. So I'll have x squared minus an x from both sides, so it'll be minus 2x. And then here I'm going to minus 3 to both sides, so it'll be minus 8. Is less than or equal to 0. So I have px on one side, my polynomial on one side, a 0 on the other of the inequality. I'm going to solve this for 0 or factor it. We'll just factor it in this case. So we'll have x minus 2 x plus 4. Yep, that works. So here I took the factors 2 and 4. I made 2 negative and 4 positive. Oh, yeah, this is a positive. I was like, that's not working because somebody didn't write the right sign. Yeah, so here you're right. Oh, I know what happened here. For the sake of argument, make this positive. Because when I typed up my notes, my old notes, I switched a sign, and that's why my brain's misfiring. Make this positive 3. If not, you're going to get 2 plus 2 minus 2, and that doesn't factor. And we want it to factor for us. Okay? So go ahead and make this a positive 3. And then this will be a negative 8. So just switch the problem real quick. All right, so here we have this. Now, I guess we didn't need to factor this. Let's go ahead and just look at it right here, right? So let's look at it right here. And let's look at it graphically. We'll solve it graphically at this point. So I'll have x squared plus 2x minus 8. All right. And I want where this is less than or equal to 0. And so just by looking at this, here I can see my two points, right? 2 and -4, right? If I didn't know what they were now, I do know what they are. I know that stuff to the left of -4 positive, stuff below is in between -4 and 2 is negative, and stuff above it is positive. And so my guess is it's going to be -4 to 2, right? But let's check it algebraically. So now we're going to mark all the zeros on a number line. So let's just mark all our zeros on the number line. So it'll be minus 4 and positive 2. Here we're going to test points. I'm going to test negative 5, 0, and 3. And we're going to write down the signs below it. And so negative 5, so negative 5, so this would be negative times a negative, therefore positive. For 0, I'd have negative 2 times 4. So a negative number by a positive number gives me negative. And here I have a 3. So this is positive and this is positive, and so it's positive. Once again, I don't really care what the sign is, so 3 minus 2 is 1. That's positive, and 3 plus 4 is 7, which is positive. All I care is the sign, so I just say positive, positive. I mean, yeah, I'm doing the math in my head real quick, but this. So notice here our sign is less than or equal to, and since it's equal to, we're going to have the bracket. And so we just want to grab everywhere it's negative. And here, where is it negative? Between negative 4 and 2. Now, does that match what we see graphically? Yeah, that matches exactly what we see graphically. Oops, nope, those are my answers. Those are the answers that I wrote out by hand. Here, this is the graphically, right? I wrote all the notes by hand while I was not next to my computer. And then when I got home, I did write all the notes. I typed them all up, but apparently I made one small typo. But you know, one small typo in like 100 plus lines of code. I'm not terribly worried about it. Will this be on the test? Yes. I'm like 90% sure. I don't know. At the end of the class, I'll double check on that for you guys. Okay. All right. So let's do one more of these. Wait, I'm still kind of confused on the solving. Okay. How to solve? Sure. Let's review what I did very slowly, and then I guess we'll have you guys work on this one. Okay. So let's review what I did very slowly. Here, I get the polynomial on one side. Here, I've already achieved that goal. Here, I needed to achieve that goal, and I did so. We're going to solve for zeros. Why? Because this is 0 here, right? And so I want to know, because either it's 0 or I make it 0, right? And so I want to know when this expression is less than or equal to 0. So it's good to know when it is 0, right? When it is 0. And so I figure out when is it 0. So here I factor it, because factoring will tell me my zeros. Either if x was 5, right, I get 0 times something, so this makes this 0, right? If I get x is negative 1, this is 0. So these are my two zeros. I guess I can write. And so these are the two zeros of the polynomial. These are the two zeros of the polynomial. Okay, so here I just write the zeros on a number line. Then, in between my zeros, I'm going to test points in between it. So this is just a test point. Could I choose 2? Sure, 2 would work fine. 3 would work fine. I just like doing 0 because 0 is super easy. So you just pick some point. Pick some point, any point, doesn't matter what, between negative 1 and 5. Could I have done negative 0.9? Sure. I wouldn't want to, but you could have, right? And then all you needed to find out is what is the sign on that, okay? And so all we need to figure out is the sign. I'll answer that question in a second, right? So here we have positive. Here it's positive, negative, or positive. And once again, and here it's positive, negative, positive. This one both follow the same thing. Notice here, we can also check that graphically. It's positive, negative, and positive. And so in this case, I wanted the values which I want this to be greater than 0. AKA, I want this to be positive. So what x values is this positive? Well, it's from the interval from minus infinity to 1, and from 5 to infinity. And so I wrote that out. I want all this to be less than or equal to 0. So where's this less than or equal to 0? Where it's negative, right? And so here I'm going to choose the interval, which I found is negative. And since it's equal, we'll include those numbers, right? So it's here and here. So now I want the negative. And so I'm going to go from -4 to 2. Okay? All right, let's do it one more time. Here we have something. Do I have the polynomial on one side and everything else on the other? Yeah, I do, right? Now I need to find the zeros of this. Well, the zeros of this, I can pull out an x, right? And then I'm left with x squared minus 1 greater than 0. Then from there, I can pull out, this is a difference of squares, which we've seen almost every day. So this is x plus 1, x minus 1, greater than or equal to 0. And then here, so here we're going to write our zeros. So our zeros are -1, 0, and 1. Here we want to find the signs of the intervals between them. And here we're just going to have some test points. So my test points here are going to be like -2, -0.5. It's not super nice, but it works. +0.5 and 2. So these are just random points I'm testing, right? Just for something to plug in. And here I'm going to be and here, just so you kind of, let's just do -2 in a lot of detail. If I plug the -2 in, I'm going to have -2 times -2 plus 1, and then I'll have -2 minus 1. So what's the sign on this? So the sign here is negative, the sign here is negative, and the sign here is negative. So I have negative times a negative times a negative, and so that overall is negative. Okay, so here the sign is negative. Here, let's do 0.5. So here, let's go ahead and do 0.5, or -0.5. And let's do this again. So notice I'm just plugging it into this right here. So -0.5, -0.5, -0.5. Okay, so here -0.5 is negative. -0.5 plus 1 is positive. -0.5 minus a 1 is negative. So positive or negative times a positive times a negative overall will be positive because these two negatives cancel each other. So this case, this is positive. All right, now we're going to do positive 0.5. So I can just go boop, boop, boop. So positive 0.5, here I'm just testing point. I'm going to get rid of this because this is no longer true. So positive 0.5 here is positive. This is positive. 0.5 plus 1 is positive. 0.5 minus 1 is negative. So this is overall negative. And then we'll test 2. So let's go ahead and plug in a 2. Boop, boop, boop. And notice I'm just plugging. I'm writing out what I'm doing in my head. The last 2 times I just kind of put these numbers in my head. So here, 2, that's positive. 2 plus 1 is positive. 2 minus 1 is also positive. So I have a positive, positive, positive. So this is overall positive. Now, which ones do I want? I want this to be greater than. So I want the positive ones. And so I'm going to take from -1 to 0. So from -1 to 0. And I'm going to use parentheses since, make that look, hold on. Make that look like a parenthesis. Since I'm not including the zeros, there's no equal here. Union, and then from 1 to infinity. Okay, and so let's graph this and see what this looks like. So let's graph this and see what it looks like and see if that matches what we got here. Hello, where'd it go? Ah, here it is. All right, so we have x cubed minus x. And we'll just kind of zoom on in. All right, so from here, from minus infinity to 1, a -1, we got negative, which matches our results. From 1 to 0, it's positive, which matches our results. From 0 to 1, it's negative, which matches our results. And then from 1 to infinity, it's positive. Now, which ones do we want? We want to solve this for all x's, which makes this greater than 0, right? So it's between any x between -1 and 0 qualifies, makes us greater than 0. Anything from 1 onward qualifies. And so then we write it out. Is this slowly starting to make sense what we're doing here? So we find the zeros, and then we just test points in between and see positive or negative, and then you go from there. Okay? All right, so yeah, so we're going to do more of these a little later. Very slowly being understood. So that's kind of what the goal is this week, is that some of the stuff is complicated. That's why I did the just-in-time notes for this week last week. And then, so I don't like this section. You'll see it today. You'll work on some of the homework tonight, hopefully. You don't have to, I suppose, but hopefully you will. And then come to me with some of the homework questions from these sections, and we'll just work through a lot more problems. And that's all we're doing next time. There'll be no extra notes. There'll be no worksheet for you to fill out. We're just going to get you through all the homework before we get to the exam, okay? So let's get to the next part of this. So the next part of this is very much like this part of this. You just do it twice, and that's all there is to it. All right, so here, so that's how we do these ones. So we're going to do the same thing now with rationals. So we're going to get a rational on one side and everything else on these there. Find all the points where it's 0 or does not exist. Basically, now you're just going to factor top and bottom. Mark all this on a number line and test intervals and mark the sign and do this. So the only difference between what we're going to be doing, what we did here to what we're doing here, is now we're going to find the zeros for the top and the zeros for the bottom. That's it. See, this is the part I don't like. Oh, this part? The rational stuff? Yeah, that's why we did all these notes, and it'll be clear why in a second. Why we went over the just-in-time notes to do this. So let's do this slowly and cleanly as possible. All right, so let's start with this one. Here, I have 3x on the top and 6 minus x. So that's 0, right? So this is as factored as cleanly as I can get it, and this is factored as cleanly as I get it, and I have my so I have my first step done. My rationals on one side. 2, find all my zeros, or the part where it doesn't exist called critical points, aka zeros on the bottom, right? So the zeros for the top one. So my zeros that came from 3x is 0, right? That's where this equals to 0. On the bottom, it's when if I have -6, right? Or -6. Or if I set the bottom equal. So basically, you're just going to set this equal to 0, this equal to 0, find all those points. Well, where does this equal to 0? At 0, right? Where does this equal to 0? When x is -6. Okay, we'll do it again here. And this one will be a little bit more clear what's going on. Now we're just going to test points like we did last time. So this will be -7, -5, just because that's easy for me to crunch through, and 2. And just figure out what are my signs. So let's start with -7. So if I have -7 here, the bottom's negative and the top's negative. And so a negative over a negative is positive. Here, if I type in -5, the bottom is positive because -5 plus 6 is 1. So that's positive, but the top is negative. So a negative over a positive is negative. And then here, if I type in 2, the top is positive, the bottom is positive, so this is positive. What are we looking for? We're looking for the negative answers because I want stuff less than 0. So I want the negative answer, so that's going to be from 6 to 0. And notice we're not including it, so it'll be from -6 to 0. Yeah, rational has always been a challenge. Yeah, we'll get through it. Let me do a couple with you, and then you'll do a couple on the homework, and then we'll do as many as you like tomorrow. From any of the sections, we'll just work on problems tomorrow for an hour. That's all we're doing. All right, so here I want to get the rational on one side and everything else on the other. So here, the only option I have is minusing 1 from both sides. So here I take, and I minus 1 from this side, minus 1 from this side, which gives us 0. So I'm just moving this over. Then I need to put this together. So I need to rewrite this as x plus 1 over 2x minus 4 minus 2x minus 4 over 2x minus 4. Basically, I'm multiplying both top and bottom by this denominator. That's how I'm doing that. Now I can put this together, and then the top part can go together. So x minus 2x will be minus x. 1 minus a minus 4, so it'll be 1 plus 4 will be plus 5. All over 2x minus 4. And we'll set that less than or equal to 0. Okay, so now I have what I want. So I'll make my little number line here. I'm going to put in, so where is this top part equal to 0? Well, this equals to 0 when x is 5, right? Because negative 5 plus 5 will give me 0. So, or if I move over, this becomes negative 5, and then divide, I'll get 5. So here, this will give me 5. Where does the bottom part equal to 0? Where does this equal to 0? Well, the bottom part equals to 0 when x is 2, right? Because 4 minus 4 gives me 0. So here you're just finding the zeros up top, the zeros down below. Once you have it as a single rational term. Okay. So those are our things. We're going to find our test points. Here we'll find some test points. Here I'll test 0. I like testing 0. We'll do 3. That's not bad. And then we'll do 6, something right afterwards. All right. And just for our ease, we're going to be using this one, right? We're going to test it here. So 0 plus 5 is positive. And then 0 minus 4 is negative. So positive over negative is negative. Here, let's do 3. Negative 3 plus 5 is positive. 6 minus 4 is positive. So positive over positive gives me a positive value. So that's positive. And then here, if I type in 6, minus 6 minus 5 is negative 6 plus 5 is negative. And then 12 minus 4 is positive. So negative over positive is negative. All right, so which ones do we want? We want ones that are less than or equal to. And so in this case, we want the negative ones. And we're going to include the 2's. And so here, the negative ones are from negative infinity to 2, and then 5 to infinity. So this will be from negative infinity, which we never include, to 2, which we are including since we have this equal sign here, union from 5 to infinity. Okay. All right, so let's actually look at these in decimals real quick. Yes, so wait, let's ask the question. How do you know? You always use both. Okay, so when you factor these, you're just going to find the zeros of the top and the zeros of the bottom, the zeros of the top and the zeros of the bottom, okay? You don't know what's going to happen, so you have to use both, but let's go ahead and type this in real quick. So I have 3x divided by x plus 6. All right, so here's our equation. I'll have to zoom out. Ta-da! Look at this happy fun little thing, right? And so here, notice here, it's always positive up until I reach a critical point. Where's this critical point? The critical point is at negative 6, right? Because the negative 6 zeroes us out. And so, while it's not like a nice clean polynomial, which will have the 0, here it swaps from positive to negative, right? And so there is a swap there. at the critical point. Here, when the top is 0, here I'm just crossing the line, and this looks more like the polynomial 0. But does this match what we have here? Positive until -6? Yep. From -6 to 0, negative? Yep. And from 0 to onward, positive? Yep. Right. So this looks exactly like we did. Here we'll do this one. Let's go ahead and type in where we have it less than 0. Graphically, if we're going to do it graphically, we do need to at least get it to this point right here. And so we're going to have minus x plus 5 divided by, oops, apparently I need to write that in. Divided by 2x minus 4. All right, so now we have this happy thing, right? All right, does this match what we got? So let's look at it. Let's zoom on in. So here notice that 2 is a critical point because it's the 0 on the bottom, right? And notice here it swaps from negative to positive this time. And then 5 is a normal 0, and this is where it just crosses the x-axis. And so we have to find both. And so in this case, it's always negative until we hit our 2, when it then turns positive, which is positive until we hit our 5, which then goes negative. Does that match what we have? Yes. Okay. And if we're allowing the zeros, we go ahead and include it. Now that I've shown you this graph, I'm going to add one more step to our answer. We have to check domain, right? And so the one thing we need to do is we need to check domain real quick. So notice 2 is not in the domain, right? So 2 is not in our domain. So since 2 is not in our domain, we can't include it. We cannot include it. So we have to change that to a parentheses. Now, why is that? Because if we put 2 into our equation, right? If I put 2 into here, I'm dividing by 0, which is not allowed. And so for these rational ones, I probably should write, so the step 3, 4, 5, I guess I should have said 6, check domain. This is why we talk about domain forever and a day, because it comes up. So we need to check domain. So the reason I'm not using this one, but this one, is because 2 is not a valid input. Why is it not a valid input? Because if I put 2 in, I get dividing by 0. So I cannot use it. So I have to throw 2 away. And so this right here is the correct answer. Okay. All right, let's do our last one for the day. So we have this puppy right here, which is far less cute than the one sleeping at my feet, as I'm sure you guys will agree. So we need to get everything on one side. So we need to have the rational on one side and everything else on the other. So what must we do? We just move over everything. So here would be x plus 4 minus x plus 2 over x minus 5 less than or equal or greater than or equal to 0. Then I must put them together. How do I do that? I multiply, just like we did in the just-in-time notes. We're gonna multiply this one by this denominator. We're going to multiply this one by, let me be very clear. We're going to take x minus 3 over x plus 4, and I'm going to multiply it by the denominator of the other one, both top and bottom. Remember that multiplying the same thing on the top on the bottom is like multiplying by 1, so it doesn't change our answer. Then I'm going to take this one, and I'm going to multiply it by x plus 4, the denominator of the other one. And the reason I do this is so I can put it together, because they have to have the same denominator. So now the denominator is the same, and this is still greater than or equal to 0. So the denominator is the same. So let's slowly do this. I'll go ahead and do it right here, I guess. So x, so on the bottom, what we're going to have on the bottom is just going to be x minus 5, x plus 4. And you know what? We're not going to change anything about that because this is already factored. So we're going to leave that the way it is, right? Now on top, I'm going to have x minus 5, x plus, so x minus 5, x plus 3. If I just FOIL that, I'll get x squared minus 3x minus 5x will be minus 8x. Negative 3 times negative 5 will give us plus 15. Then we're going to minus out what I get from here. So minus everything here. So this would be x squared plus 6x times plus 8. And this is less than or equal to 0. All right, so now we just put these two together. So the x squares cancel, so I'm just left with minus. So x squares cancel. Then I have minus 8x minus a 6x would be minus 14x. And then here I'll have plus 15 minus 8, which would be plus 7. And then this is all over x minus 5, x plus 4. So all I did was just add this polynomial to this polynomial. I get this is greater than or equal to 0. Now we can finish our problem, right? Now we can finish our problem. What's the zeros for the bottom? Well, the zeros for the bottom are the following. It's 5 and minus 4. So minus 4 makes this 0. 5 makes this 0. What makes the top 0? A half, right? Because 14 times a half would be minus 7. I could solve this. Let me solve it really quick. So minus 14x plus 7 equal to 0 means that minus 14x is equal to minus 7. So x equals 7 over 14, which is equal to a half. Okay, so that's where I get the half from. I think I'm going to need to save this room, so I'm not going to actually have this on the notes. So now what we do, we just test points in between everything. Okay, that's a 7. All right, so let's test. Minus 5 seems not bad. Here we can use the 0. That's pretty good. Here we can use, I don't know, 2. Oh, screw it. Let's just use 1. 1's easier, right? 1. And then here we can just use 6. So I'm just picking random points in between all this. So negative 5. So up top, if I have negative 5 times this becomes massively positive. So this is positive up top. Negative 5 times a negative is definitely negative. And then this is also definitely negative, but negative times negative. Let me actually type in the negative 5. Let me show you this. So minus 14 times minus 5 plus 7 all over minus 5 times minus 5 plus 4. Let me do this one where you can actually see what I'm thinking in my head. This becomes positive. So the top is massively positive, right? This is negative, but negative times a negative makes the bottom positive, right? So positive over positive, this is positive. Okay, let's do it for 0. And then I'll just give you what the other two are. Okay, so we'll do it 0, 0, and 0. So this is positive 7, since this cancels out. So I'm negative and a positive. So positive, negative, positive. Doesn't matter if it's top on bottom. If you have an even number of negatives, 0 or an even number of negatives, it's positive. If you have an odd number of negatives, it's negative, just because that's how it works out. So here I have positive, positive, negative, so that's an odd number, so this is negative. If I plug in a 1, if I plug in a 1, the top is negative. The bottom, this is negative. This is still positive. And so this becomes positive overall. And if I plug in 6, the top part is negative. But this too is positive, and so it becomes negative overall. Okay. And we'll double check this. How we're going to double check this? We're going to type this right here into Desmos. Hi, Desmos. So it's what? Minus 14 plus 7. And then on the bottom, I have the quantity of x minus 5, x plus 4. Okay, so we have this awful looking graph, right? And so notice here at minus 4, I have one of my critical points, right? Here at 5, I have a critical point, and then here at a half, I just have my normal transition. So remember, stuff up top will give you normal transitions. Stuff down below gives you these really weird looking, where it just jumps, right? Where it just jumps from one end to another. But all we really care about is sign. So let's look if it matches the signs we got. It's positive up to negative 4. Yep. From negative 4 to a half, it's negative. Yep. From a half to 5, it's positive. Yep. And then from positive, and then from then onward, it's negative. Yep. So that matches what we have. And so we can easily check. So if you have trouble, since we're doing this remotely, and you always will have access to a graphing calculator, aka you can always just open up Desmos. If you don't like testing the points, you can just look at the graph, okay? All right, now that we have that, let's put it together. So let's write our, I'm gonna go ahead and get rid of this just so I have room. I should have left more space. Note to self when I rewrite these notes, put them on other pages. All right, so we want greater than or equal to. So I want the positive values here. So I'm going to go from minus infinity to 4 include, right? Because I can include that point. Union from a half included to 5 included. Then what's the very last thing we need? We need to check our domain, right? So we're going to check the domain here. I need to throw away 2 of these points. Which points am I throwing away? 4. Or sorry, that should be minus 4. Somehow my negative did not exist. I need to throw away negative 4 because that's not in the domain, and then positive 5 because that's not in the domain. So we check the domain, and then we get our real final answer, which is this. 4 union bracket, a half, 5 brace, okay? That should be, oops, somehow I forgot my negative again. Come back, negative. Okay. So once again, we check the domain, basically throw away the zeros on the bottom anywhere if it was in your interval. Okay, if you need to go, that's fine. That's the end of the notes. So you're not leaving that early. All right.